So one of my key science questions really is trying to understand how snow and stream flow are related. And so sort of tracking that water molecules from source to the stream itself. My name is Rosemary Carroll. I'm a research professor at the Desert Research Institute. I've been with DRI since 2000, so 24 years. And I live here in Crested Butte, Colorado. I've had interviews in Las Vegas about snowfall in that area and asking if that's going to actually help Lake Mead. And I'm like, well, no, most of your water is coming from here. It's coming from the headwaters of the Colorado River system. And so understanding how snowfall, for instance, moves into and through the headwaters into the stream and downstream to support agricultural communities, municipalities and industries, as well as the environmental needs of that water becomes critical. We need to understand these systems. Kind of the canary in the coal mine too. These systems are warming faster than other parts of our globe, and it's changing the snow dynamics in ways and the feedbacks that has in terms of vegetation water use, groundwater generation, and how that all influences stream flow is highly uncertain in these complex environments. We'll start from the top, which is the snowpack. We dig a lot of snow pits, and the snow pits will allow us to look at depth of that snowpack and density of that snowpack. We also have been collecting the chemistry and the stable water isotopes of that snowpack. We can tie that to the stream flow and say, well, that snow came from that location. We also tie our snow pits with airborne LIDAR, so we can map at a very high resolution snow depth. And we can use that in not only trying to better understand runoff that year in terms of stream flow, but we can use that to help us validate model predictions of snowpack. So we use that information. So moving from the snow, we move to the vegetation. Vegetation type and distribution, like how dense is that canopy, what type of vegetation is that, helps us better understand when it's using that water. We know that vegetation's rooting depth. We understand how precipitation might land into the canopy and then evaporate back up into the atmosphere. And we can also use remote sensing and other airborne surveys to look at vegetation greenness, vegetation health, and that type of thing. And we can link that into our modeling platforms. Moving down into the soil, we collect soil temperature, soil moisture, soil chemistry, soil microbial constituents within there. And that we use also to help in our hydrology understanding, but also in terms of vegetation health and vegetation water use. So they all kind of link in together. Then we have groundwater. We have wells we've drilled. You don't drill wells up on the tops of these mountains. That's not where people are drilling for water use for irrigation or municipal use. So we have to drill wells where we can and collect water level data and water chemistry data. And then lastly, we collect a bunch of stream flow data. So we go out and wade in the river, collecting measurements of velocity, and then we also put in transducers to measure depth, temperature, and then we have a whole suite of constituents that we sample, both high frequency of time, like dissolved oxygen, temperature, turbidity, and whatnot, and then we have synoptic samplings where we sample for chemistry along stream reaches to try to better understand how stream flow and stream chemistry is changing along specific reaches. So we do all of that, and we use a lot of that information to combine the data, but also to help inform our models. We are a system under change, and I think that as a scientific community and a community that either cares about or relies on water resources in some facet that it provides for us, whether that's economics, municipal, environmental, recreation, we're all part of the solution. We can't do it by ourselves. It's very hard to understand these systems as an individual scientist. You need a consortium of scientists. You need better science, more science, to better understand how that change, where it's happening, how can we mitigate that change if we can, to help build that resilience into our communities within the basin. And by within the basin, I mean the whole Colorado Basin, because the lower basin is not, there are definitely legal differences, political differences, but hydrologically we're connected. And so understanding how to work together is really kind of my overall story. We can't do it alone. We can't do the science here alone. We have to kind of all work together toward a common solution.